All right, so I think this is recording. Let's take a look here at problem number 1. They give us a polynomial function. They want us to factor it and then identify the zeros and also identify the multiplicity of each zero and to indicate how it intersects the x-axis. So to factor this, well, we don't have any kind of x method or any kind of a tool to factor something that's x to the 4th power with these 5 terms. But we do have synthetic division. If they're telling me that x equals -1 is the zero of the function, then I can use the remainder theorem and factor this. So I've got 1x to the 4th. Let's make sure this is in standard form with no missing powers. 4, 3, 2, 1, and a constant. So I don't have to worry about putting any zeros over here in my synthetic division. If it really is the case that -1 is a zero, I should get a 0 as a remainder right here, so let's see if I do. And it looks like that's exactly what we get. So this allows us to factor this p of x. I know that in factored form, because -1 is a 0, x plus 1 is a factor of this polynomial. And now for my synthetic division, I can write this as 1x cubed plus 6x squared plus 11x plus 6. Well, I don't have, again, I'm stuck with the same type of problem I had at the beginning. I don't have any kind of method or a way to factor this polynomial, this x cubed. You know, we don't have an x method for something like x cubed, but I haven't used all of the information from the table. It says the multiplicity is 2. I've only used it once right now. I can come in, and what we know is that this new x to the 3rd polynomial here, that x plus 1 has to be a factor of it. So this factors, and one of the factors is x plus 1. So let's come in. We know that we've got this x plus 1. Let's do synthetic division on what I've highlighted there. So 3, 2, 1, and a constant. I don't have any missing terms. 1, 6, 11, 6. If it's true that this x plus 1 is also a factor of this polynomial, I should get a 0 remainder. Let's see what I get. And we do. We get a 0 remainder. So let's shrink this up so I have some more room to work. So this p of x is equal to x plus 1. And now what I've highlighted there factors to x plus 1 times x squared, because it's 1 degree less than what I did the synthetic division when I started at x cubed. The 3 minus 1, this is starting out x squared, plus 5x plus 6. All right, let's set this equal to 0. Let's write x plus 1 and go ahead and combine these two factors. And x squared plus 5x plus 6 factors pretty easily. The leading coefficient is 1. So we have 6x squared. And down here 5x. Well, two numbers that multiply together to give us the top expression, but add to give us the bottom are 2x and 3x. Since the leading coefficient's 1, we've got our shortcut that we can just say x plus 2 times x plus 3. So from the zero coefficient theorem, zero product theorem I mean, if I have a product of numbers that equals 0, then at least one of the factors must be 0. So this guy gives me that x equals -1. It has a multiplicity of 2. That's already in the table. Or -2 is a 0 of a multiplicity of 1. So I've got x equals -2, a multiplicity of 1. That exponent is 1. So I know this is a cross. And over here, x plus 3 If it were to equal 0, x would be negative 3. That multiplicity is 1 as well. And so it's a cross. So we're done. Here. They wanted us to write this in factored form. So here it is. Here's that polynomial completely factored. All right, so I hope that helps, and I'll talk to you later. Bye.